Hi, my name is Yogesh Prabhu, and this is a series on multiple integration. And I'm going to solve 11 key questions, okay, one by one, and this is question number 2. And let me tell you something that question number 2 is perhaps the most conceptually important question. You really have to understand many things over here, and I'm going to go really slow about all this. So pay attention, okay. So, what this question is all about that you are supposed to evaluate this integral and notice that the limits are not given, okay. Now instead of giving the limits, they have mentioned that the limits of integral are over the area enclosed by these two curves. And how do we figure out the limit? Here we go. So let's get started, okay. The solution, okay, I find the limits by drawing these two curves. So let me draw a graph for that. Well, this is x-axis and a y-axis, okay, and we can figure out the second equation. That's very easy, right? Y equal to x is a 45-degree line, right? If you can plot, okay, one point is going to be 0 0, another point is going to be 1 1 2 2 3 3 and so on so forth. It's a 45-degree line. Let me draw that. Let's say this is say a, this is x is equal to a, and if that is x is equal to a, this is going to be y is equal to a, and this point over here is a comma a, right? So now y is equal to x is going to be a line like this, okay. Now that's the blue line there. You should always write down the equation of a line. So that is y is equal to x. I write that as well. Well, and next is we want to figure out what is going to be y square equal to ax. So if you see square, it is definitely not a straight line. Okay, we know it's a parabola, right? So y square equal to ax is a parabola. Now y square equal to 4ax is a standard parabola, right? Y square equal to 4x is a parabola which will open that way. So you can figure out the points. So if you have x0, then y will be 0. And x is a, the y will be plus or minus. I can just like plot it, and it's kind of a standard shape as well. So the parabola goes like this, and it's going to be on the other side like this. And the equation of parabola, I just have a habit of writing equations every time. So it is y square equal to x. Okay, fine. So we have the question says that area R is the area between the line and the parabola. So if you see the common area between line and the parabola, okay, what you should do is quickly, shade that area between the red and the blue line. Well, so this is the area, okay, the region R. So once you figure out region R, next what you should do is we want to figure out the limits of integral and see how we do that. For this, what you can do is you can take a vertical strip, okay. So I'll take a vertical strip. Now just learn the procedure first. Well, take a vertical strip in the shaded region R of yours. So I took this as a vertical strip. Now there is a technique to that. Now this vertical strip over here, okay, the first rule is it will never go outside the shaded area. That means that strip will be strictly from here to here only. This is a technique of finding or evaluating the limits. And also the strip is not fixed, okay. This strip moves, and it moves parallel to itself. So it is going to be moving like this. It's going to go all the way till there to all the way till here. So basically it can go here, okay. So it can go here, and last point it will reach is till here. That's its right bound, and on the left side it will reach last is over here, and from that you figure out the bounds. Okay, so one of the bound of this vertical strip is going to be this y-axis, which is nothing but x equal to 0 over here. And the rightmost bound of the strip, yes, you're correct, that is this x is equal to a. So now the bounds of the vertical strips are x is equal to 0 to x is equal to a. And also you figure out, if you see that the strip is like moving, right? It moves parallel to itself, but no matter where it goes, okay, the lower limit of the strip will always remain on this blue line, and that's where you get the lower limit of y. And lower limit of y is as per the equation of blue line, which is x and upper limit of the strip, that it always rests on the red equation, the parabola, and that is y square equal to ax. So you can write this y upper is equal to root ax. So from this region, with the help of vertical strip, we figured out the limits of integral. And let me write down those limits. Limits are, well, you have x going from 0 to a, and y will go from x to root ax. Now you can use these limits on that integral and we can now solve the integral. See how it goes. First let me call this, let's say this integration is I, and I is going to be double integration, but now I have the limits as well. So the limits are x is equal to 0 to a and y is equal to x to root of x. Well, now let me write the integral as well. Y is equal to a minus x root of ax minus y square dx dy. Now I have the limits as well. So once I have the limits, I can easily, solve this one. Now I hope you remember that we always evaluate inner integral first. And if you see inner integral is of y, so we'll integrate limits in terms of y. And we will just treat x as constant. So let me take x out. This is going to be I. Integration x is equal to 0 to a. I can simply take that 1 upon a minus x out, because I'm going to integrate inner integral first, which is y is equal to x to root of ax. Okay, so I get this is ax minus y square raised to minus half. Okay, and then I have got y dy and dx is out. So I'm focusing only on this integral. Fair enough. Once I write like this, now I don't know if you remember this formula. There is a formula, right? That if you have an integral and a function raised to some number n and derivative of that function, the answer of this integration is function raised to n plus 1 upon n plus 1. We can very much use this formula. Can we? Hey, do you see this is the function? F. And that is f raised to minus half, that is the value of n. And along with that, you want the derivative of the function, and the derivative of the function, what is the derivative of ax minus y square? Now understand, while you're integrating y, you're treating x as constant. So your ax is constant, okay? So if you differentiate this, the derivative of f would be 2y, well, minus 2y. So I should write minus 2. This is an arrangement. Okay, I just minus 2. So I write minus half outside. Now this is precisely f dash. Now if you see, it is exact same format that we always want, right? Function raised to some power, okay? And this is a derivative of the same function. And if that is the case, the answer of this integration is going to be function raised to n plus 1 upon n plus 1. So now we can use this particular formula, and the inner integral is already solved. See how it goes. Well, I is going to be minus half outside, x equal to 0 to a, 1 upon a minus x as it is. Okay, and what is the integration of this one here? This is function raised to n plus 1, n is minus half. So minus half plus 1 is going to be half. Well, this is going to be ax, the function, ax minus y square raised to minus half plus 1 upon minus half plus 1. And that limits will go from y is equal to x to root of ax, and dx is still remaining. Alright, so now once we do that, this is minus half plus 1 is half. This is also half. Let's substitute the values. What do we get? I is equal to, well, this term will cancel out with this half. The minus is still there. Negative x is equal to 0 to a. Well, 1 upon a minus x, and let's substitute the values. This is anyways half. Upper limit, when I put y equal to root ax, the upper limit is ax minus x is 0. Upper is 0. Minus the lower limit, when I put y is equal to x, this will be ax minus x square raised to half. and dx. Now we just have to integrate this integral over here. So let me write that. See, minus and minus will cancel out. So you would get this I is integration x is equal to 0 to a. Okay. And then this is 1 upon a minus x. 1 upon a minus x. And minus is already cancelled out. You can take the x out from here. So it is x raised to half. And this is a minus x raised to half as well, dx. Alright, so we got that one. Now, if we have to solve this integration, there is a technique of solving integral. See, whenever you come across any integral, okay, the best way to solve an integral is by a method of substitution. So here we can do that substitution and get the answer really quick. What should be the substitution here? Okay, what I can do is I can put x is equal to 80. Now once I get x is equal to 80, and if I differentiate this, I would get dx is equal to a dt. Well, the limits will also change. The original x limits were from 0 to a, and the limits of t will be put x is equal to 0, t is 0, and put x is equal to a, t is 1. Now you convert entire integral from a variable x to variable t. Let's do that. Here, this is going to be I. Well, integration will be for t, that will go from 0 to 1. That is the new limits of t. And this will be 1 upon a minus at. And then this will be x is at raised to half. This is a minus at raised to half. Dx is equal to a dt. Now let's write this whole thing. I is going to be integral t is equal to 0 to 1. Then, well, you take a out. So this is a raised to minus 1, this one here. So it's just 1 minus t right now. And then this a raised to half, you can take it out. So it's just t raised to half. Then take this a also out. You get 1 minus t raised to half, and this a raised to half comes here. And now this is dt. Now this a also is outside, so it is plus 1 again. Now once we write all of this, I get I is equal to, well, minus 1 plus 1 is cancelled. This is just a. And then, well, this is integral t is equal to 0 to 1. And this is t raised to half. This is 1 minus t raised to half and minus 1. This is minus half dt. Is that correct? Now, if you look at this is a good candidate for beta function, right? You have limits going from 0 to 1. So simply add 1 and subtract 1. And do that here as well. Add 1 and subtract 1. And now this blue highlighted integral is nothing but beta. So we write down this as I is equal to a. This is beta. This is 3 by 2, comma 1 by 2. And if you solve this question, okay, you can easily find out the answer of the integral I. And this is how you find out the limits of integral when they're not given. Okay, this is question number 2, and in the next video I'll be solving question number 3 of the list of 11 questions. Thank you.